Hello students, so in this video we will prove the relation del equals to I1 plus I2 minus A. Del is the angular deviation, I1 is the angle of incidence, and I2 is the angle of emergent, and A is the angle of prism. Okay, so angular deviation of light ray during refraction of light through prism. We will see this relation. Make sure watch this video till the end and you will learn to derive the relation. Okay, so let's begin. So this is a prism, okay, and this angle is called angle of prism and is denoted by the letter A. Okay, a ray of light is incident on a prism. So if there was no prism, the ray of light would travel in a straight line like this, isn't it? In absence of prism, the ray of light would travel in a straight line. But due to the presence of prism, okay, the ray of light is deviated. You know, this is the normal. Normal means a straight line perpendicular to the reflecting surface. And this is the reflecting surface. And this line is a straight line. Perpendicular means this line is at 90 degree to the reflecting surface. So this is the angle of incidence, isn't it? This is the angle of incidence, and due to the presence of this prism, the ray of light is deviated towards the normal, isn't it? When the ray of light enters from rarer medium to denser medium, the ray of light deviates itself towards the normal. So this is normal. The ray of light is deviated towards the normal. Okay. Okay, now this is the reflected ray, isn't it? This is the reflected ray, and this is the angle of refraction, isn't it? This is the angle of refraction and it's denoted by R1. Okay, now here also the ray of light meets another refracting surface, because after this refracting surface the ray of light will emerge out from the prism, isn't it? So here we need another normal. So this is the normal to another refracting surface. Okay, this normal is also perpendicular to the refracting surface, isn't it? So this normal and the first normal meets at this point. Okay, now after refraction, the ray of light enters the rarer medium. That means the ray of light will bend away from the normal. So the ray of light will travel in this direction. Okay, and this is the angle of emergent, that is I2. Okay, and this is the first angle of refraction, this is R2. Are you getting me? Now what is the angle of deviation here? Angle of deviation is if there was no prism, the ray of light would travel in this direction straight away. But due to the presence of prism, the ray of light is bent in this way, isn't it? So the angle of deviation is nothing but the angle between the incident ray and the emergent ray, isn't it? The angle between the incident ray and the emergent ray is called the angle of deviation. In absence of prism, the ray of light would travel straight away like this. But due to the presence of this prism, the ray of light is bent to this direction. So what is the angle of deviation here? If we extrapolate this ray of light backward, okay, the refracted ray backward, then this line would meet here, isn't it? So this is called the angle of deviation. This is called the angle of deviation and is denoted by the letter delta, okay, small del. So this is the angle between the incident ray and the refracted ray. This is called angle of deviation. So we are asked to prove del equals to I1 plus I2 minus A, isn't it? Now let us assume this is P, okay, this is P, this is Q, this point is Q, this is R, and this is S. This point is S, this point is Q, this point is P, and this point is R. Okay. Now in quadrilateral, what does the term quadrilateral mean? Quadrilateral. Quadrilateral means plane figure having 4 sides. Like this is a quadrilateral, isn't it? This is a rectangle. Rectangle, it has 4 sides, 1, 2, 3, 4. This is a quadrilateral. This is a square. It also has 4 sides. This is a quadrilateral. This is a parallelogram. This also has 4 sides. This is a quadrilateral. This is a trapezium. This has 4 sides. This is a quadrilateral. Similarly, this is a rhombus, isn't it? This has 4 sides, and this is a quadrilateral. Okay, quadrilateral means any plane figure having 4 sides, and you know that the sum of all the angles of quadrilateral is 360 degree. Suppose let's take an example of rectangle. Okay, this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. If you add up all the angles of this quadrilateral, this is a quadrilateral, isn't it? The special name of this quadrilateral is rectangle, but as a whole we call this a quadrilateral. So when we add up all the angles, 90 plus 90 plus 90 plus 90, we get 360. 90 into 4 is 360, isn't it? So in quadrilateral, PQRS, okay, this is a quadrilateral, isn't it? This is one side, this is another side, this is another side, and this is another side. 1, 2, 3, and 4. 4 sides. In quadrilateral, PQRS, okay, angle P, this is this angle, isn't it? Angle P plus angle Q plus angle R plus angle S. Angle P means this angle, angle Q means this whole angle, angle R means this, angle S means this whole angle, okay, whole angle, equals to 360 degree. Are you getting me? Sum of 4 angles equals to 360 degree in quadrilateral. Now, or angle P plus angle Q, okay, angle Q is 90 degree, isn't it? Angle Q, this angle is 90 degree because this line is perpendicular to the refracting surface. This angle is 90 degree, isn't it? Because this line is perpendicular to this line. Perpendicular means 90 degree. So angle Q is 90 degree plus angle R. Angle R is A plus angle S. Angle S is also 90 degree, isn't it? Because this line is perpendicular to this line. So this angle is 90 degree. So 90 degree equal to 360. I hope you are getting me. Or angle P plus angle A. Angle A can be written as A, okay? Angle R is angle A, isn't it? Angle A equals to 360. 90 plus 90 is 180, isn't it? So 180 we take to the left hand side, right hand side, minus 180. Or angle P plus angle A equals to 360 minus 180 is 180. So this is equation 1, okay? Now in triangle PQS, okay, the small triangle here, PQS, I am talking about the small triangle. In triangle PQS, angle P plus angle this one, this angle plus this angle equals to 180 degree, because sum of all the angles of a triangle is 180 degree, isn't it? So angle P plus angle PQS plus PQS means this, PQS means this angle plus angle QSP, angle QSP means this angle, isn't it? Equals to 180 degree. So angle P plus PQS is PQS is R2 plus angle QSP is R1 equals to 180. So this is equation 2. In equation 1 we have angle P plus angle A. Angle A means A, okay, we don't need to write angle here. Angle R is angle A. So angle P plus angle A is 180 and angle P plus angle R2 plus angle R1 is 180. So 180 equals to 180. 180 and 180 are same. So from 1 and 2, we can write this right hand side 180 and 180 are equal. That means this and this should be also equal, isn't it? Because their sum is equal to 180 and their sum equals to 180, means this should be equals to this. Therefore angle P plus A, okay, equals to angle P plus, let us write this R1 first and then R2, okay, plus R1 plus R2, isn't it? Or this angle P, if you take to the right hand side, it becomes minus angle P, and that minus angle P and this angle plus P will be cancelled. So let us cancel here itself. Or A equals to R1 plus R2. This is equation 3, okay. A equals to R1 plus R2. Please take the screenshot. I am erasing the upper part, okay. I'll continue. Now in triangle, suppose this is N, okay, SQN, in triangle SQN, in triangle wait, in triangle SQN, SQN means the upper angle, isn't it, the smaller one, SQN, angle NSQ means this angle, isn't it, NSQ, angle NSQ equals to NSQ, this angle equals to this angle is I1, isn't it, I1, angle of incidence is I1 and angle of emergence is I2, okay. I1 total angle minus R1 is this angle, I1 to this angle, this I1 is this angle total, isn't it? So I1 minus R1 gives us this angle, NSQ equals to I1 minus R1, and angle NQS equals to NQS equals to this angle, isn't it? This angle equals to angle I2, whole angle is I2, this I2 is equal to whole angle. So I2 minus R2 gives us this angle, smaller one. Total angle I2 equals to this whole angle, isn't it? So I2 minus this R2 equals to the upper angle. So I2 minus R2, are you getting me? I2, this I2 is the total angle. So I2 minus R2, this I2 minus R2 gives the upper angle. So the external angle, you know that this is a triangle, okay. Let me draw properly. This is a triangle. I'm just giving an example, and this is called the external angle. This external angle, we have the theorem in triangle, okay. This external angle equals to sum of these two internal angles, okay. This external angle equals to sum of two internal angles. The external angle that is del, isn't it, in triangle NSQ, SQN or NSQ, same thing. NSQ or QNS or SQN, the same thing. The upper triangle. In the external angle del, I am talking about this NSQ, the upper triangle. The external angle del, okay, equals to this angle NSQ plus angle, because this external angle equals to sum of two internal angles. So angle NSQ plus angle NQS, isn't it? Or del equals to NSQ is, what is NSQ? NSQ is I1 minus R1, I1 minus R1 plus NQS. NQS is I2 minus R2, I2 minus R2, isn't it? NQS, this angle is I2 minus R2. So let me continue, okay? Or del equals to this I1 and I2, let me write first. I1 plus I2 minus, okay, minus R1 minus R2, let us take minus common, R1 plus R2, minus into plus, minus R1, minus into plus, minus R2, okay? Or del equals to I1 plus I2 minus R1 plus R2 means R1 plus R2 means A, isn't it? A from 2, oh sorry, from 3, equation 3. So this is the relation which we were asked to prove. Del means angular deviation in prism equals to angle of incidence plus angle of emergence minus angle of prism. Okay, I hope you got this. Thank you so much for watching this video.